Come on. Three of a kind. That's what I mean. Three of a kind.
So you guys see dice, but your brain is actually playing a much cooler game. It's called RBC theory.
RB what?
Recognition by components. Think of it as the Legos of the universe.
We're playing Yahtzee here, not Legos.
Actually, you are. See these dice right here?
Mm-hmm.
These are cubes. In our brains, we have a mental toolbox of about 36 shapes called geons. Bricks, cylinders, cones. Everything you see is just a bunch of geons snapped together.
So a die is just a cube geon?
Exactly. And the best part, your brain is a pro at this.
Even if the dice are spinning or half hidden under Lucas's hand, your brain recognizes those straight edges. It doesn't need to see the whole thing perfectly to know what it is. Scientists call that viewpoint invariance, but you can just call it brain power.
Look at Lucas's soda can. That's a cylinder geon. Isn't it awesome how we see the different geon shapes as they come together? That is so awesome how we can even see a cube geon in the die.
So my brain just picks everything up into simple shapes.
Every single time, as long as your eyes can see where the shapes connect, like where your handle hits the mug, your brain solves the puzzle in a split second.
Too bad my brain can't figure out how to get Yahtzee. I rolled all two.
Well, the theory explains how you see the dice, Lucas, not how to be good at the game.
But how do we recognize more complex things? Like a...
This is a dog. That's what 99% of you all thought when you first saw him, right? But why do we instantly think of dog or glasses or coat? That, ladies and gentlemen, is called basic or entry level categorization, a natural level of categorization that easily comes to mind. But how else could we categorize this dog? Some of you may correctly categorize this dog as an animal. You would be correct. Some of you may also categorize this dog as a French bulldog, a beautiful boy named Obed, and my lab assistant. You'd also be correct. Those are the two other levels of categorization: superordinate, a general level for categorization, and subordinate, an incredibly specific level of categorization. But what do we base these categorizations on? Close your eyes. Think of a dog, the most perfect dog you can think of, the bestest dog you can think of. That could be described as your dog template, an internal representation of a dog in your mind. But templates can be anything: phones, ties, floors. But you may think to yourself, not all dogs are the same and not all floors are the same. Exactly. You can recognize these dogs, but you can also recognize that they are not this dog. That's because we don't recognize on a point-to-point basis. It is more of a conceptual definition.
But how would we recognize something more human?
Hey, you want to try an experiment really quick? I want you to picture your best friend's face. Got it? Okay, what did you see? Did you see two eyes, a nose, a mouth, maybe floating around separately? Or did their whole face pop into your head like a picture? Would you like to know why that is? That is actually because your brain uses a shortcut that's called holistic processing. It doesn't just see parts. Instead, it sees the relationship, like exactly how much space is between the eyes and the mouth. Take a look at this beautiful smiley face drawing of mine. It's fantastic, I know. He's upside down, and he looks pretty normal, right? You see 2 eyes, a nose, and a mouth. Nothing weird here, right? But here's the secret. When a face is upside down, your brain's whole face shortcut turns off. It stops looking at the distances and only looks at the pieces. Since a dot is just a dot, your brain says, looks fine to me. Watch what happens when I flip it right side up. When the smiley face is right side up, your brain's shortcut turns back on. Suddenly, my smiley face doesn't look so cool anymore. In fact, it looks pretty weird, right? Those eyes are way too far apart. Now that it's upright, your brain is instantly checking its face map and realizing that the relationships are all wrong. So the next time you see your friend, Remember, your brain isn't just looking at their eyes and nose. It's checking its secret internal map, just to make sure everything is exactly where it should be. And if you want to know something, you can totally try this experiment at home. Just draw a face, flip the mouth, and show your parents while it's upside down. See if you can trick their brains. Anyways, stay curious.